All right, so today what we're going to do is compress a disk image that we have for this Debian virtual machine. The other day I had to download a bunch of files in order to install some software. And then after I deleted the files, of course, the virtual disk image had expanded in size and was taking up a bunch of disk space. So this is a good opportunity for me to show the process for compressing the disk back down to its minimum size. So I think the first thing that we're going to do is we're going to create a file that essentially fills the disk, the virtual disk, completely. And we can easily do that by just creating a file that's full of zeros. So we use a dd command to pull zeros. So there's a device literally called zero, and it just emits zeros. And then what you do is create a file, and you just keep building that file bigger and bigger until finally it fails. And then, of course, we just delete the file. Now, why does this work? It works because normally when you format a drive, it does a very quick format. It creates a table of contents at a table at the beginning with the pointers to all the files in the system, but it doesn't really touch the rest of the empty space. So when you go to compress the virtual drive, that those random bits can't really be identified as being nothing. But in this way, what you've done is you've essentially marked the empty space on the drive, which makes it possible for you to use a command that can take those areas that are just empty space and remove them when it's doing a clone. So in this case, what we're doing is we're telling qemu image to take the original drive and create another drive, but with the -c flag. The -c says to compress. So what you'll notice in the top left-hand corner here is that the original was around 90 gigabytes in size. And the clone is currently 3 gigabytes, but I believe by the time it's done, it'll be something like 5. Now, of course, I've sped time up a bit here. That's why you see the cursor blinking quickly. And so now what we do is just move the bloated image over to some other name, and then take our new compressed one and give it the original name. And then of course we'll test it by starting up the virtual machine. Excellent. There you go. It's all working perfectly. It still believes it has, you know, a 90 gigabyte drive, even though physically on disk it's only taking up 4.5 gigabytes. And now finally we can just delete the originals